What is the nature of space and time? How does the universe fit within us? There's no better mind to guide us through these expanding questions than my guest, the acclaimed astrophysicist Neil Degrasse Tyson. His book, Astrophysics for People in a Hurry, is very small, as you can see, but it is so packed with information. I'm doing 2 episodes with Dr. Tyson. This first one takes us from the Big Bang to Isaac Newton, while part 2 will take us from Newton to the present. I don't know where to begin, Neil. You saw everybody from the crew to whatnot all having their Neil deGrasse Tyson shirts on, their NASA shirts, everything. They are so excited to have you here, and so am I, sir. It is a pleasure to have you on the show.
I prefer you have lower expectations, then I can exceed them, okay?
Oh, well, I'll tell you what. There's no way you cannot exceed them. I read this book, and that's why we're doing even 2 episodes. As I mentioned in the beginning, this book is small, it's compact. It is really for the layman to understand, but it is so focused with so much information, I needed to break it down. And as I say in the beginning, we're going to go to this episode from the beginning of the Big Bang to Newton, because that's kind of in the beginning. And we're going to take it from there to the present in our second talk.
Well, thanks for making note of this, because people joke with me after they hear the title, Astrophysics for People in a Hurry, and they ask me, well, how come you didn't name it Astrophysics for Dummies? And I say, well, first, that title was taken, but second, it's not for I mean, it's real astrophysics. It's just for curious people who really don't have all that much time to sit down and like on a beach. I mean, people work or have school, have kids, and it fits in there because you can dip in and dip out, and so that was the goal.
And what I find it does for me is it sparks so much thought. It almost feels as if, I said this earlier to some friends, I remember the image of Tycho Brahe sitting in that little chair where he would just stare at the planets. This makes you want to do that. It makes you want to just go outside, look up, and stare.
Ideally, it will turn you into a person who will make time to read bigger books about the universe. This one will just get under your skin and say, I need more.
Yeah. Well, I want to start with your words, your opening quote. The universe is under no obligation to make sense to you, but I know you believe this and I know I believe it. Our purpose, though, is to make some sense to the best of our ability of it.
Sure, but I don't want to dig too deeply into semantics, but what I will say is we have our 5 senses. You know, the traditional senses: sight, hearing, taste, touch, and I leave one out, sight, smell. And our lives are, our understanding of the world around us is shaped by how we receive that world through these senses. And one of the objectives of modern science is to remove the role of your senses in any of this and create measurements of what is true, whether or not your senses experience it. So someone can walk around and say, oh, I have a 6th sense. And we all know what they mean by that. They can know things in ways that the rest of us can't. And I'm just simply not impressed, because in science we have 100 senses, right? We can measure things that your physiology is incapable of even noticing. And as a result, it is likely that we will make some discoveries that literally do not make sense to you. Because they fall outside of our sensory experience.
Those are the biggest ones. I mean, if you think of Newton, if you think of Einstein, those were people that were not even measuring scientifically, but thinking outside. They had to be, I guess, was it counterintuitive? I think that's the
phrase.
Close to the right word to it. Because if you are just like they did, you would think you are the center of the universe. You would think everything revolves around, and it was those people that could think literally outside of their senses that brought the realization to us of what is.
And one of the great revelations to rise up out of that movement was how susceptible we are to hubris, human hubris, to our ego. To sit, oh, this is here just for me. Oh, these stars moving in the sky, they know I'm here and they influence me. This whole universe is revolving around us. This river floods and irrigates the land for me. There's this notion that somehow nature has us as its goal and its objective. And so much of cosmic, especially cosmic discovery, but also discovery in other disciplines, dismantles this sense of self-importance and puts us in a proper context with nature.
So you mean to say that my mother was always wrong when she said I thought the world revolved around me?
No, she's correct that you thought it was. That's different from it actually revolving around you. You would think that. That doesn't make it real. But getting back to your point, there are things about the universe that you should not invoke what makes sense to you as a judgment for whether or not it's true. So that's what I mean. The universe is under no obligation to make sense to you. You can come back to it and say, that's amazing. Take, for example, I don't know if you were going to get there later. Take, for example.
I'm getting everywhere,
You're
by
getting
the way.
everywhere.
That's where we're doing two parts.
I won't
but
overstep.
Go ahead.
No. If I just pull it out for a moment.
Sure.
Antoine van Leeuwenhoek, who was a Dutch scientist who perfected a version of the microscope, a compound microscope, enabling him to see things smaller than ever before. And he was the first to take a drop of pond water, to even think to do this. Here's transparent water just from a local pond, and put it under a microscope. Why even think to do that? This is brilliance. He does this, and what is revealed is an entire colony of single-celled organisms, just doing the backstroke in the drop of pond water. So you can explain that to someone. I found animals swimming in a drop of pond water. You'd think I'm crazy. It doesn't make sense to you, because animals have some size in your mind. They have some needs. They have some environments in which they thrive. And this violates every one of them. So you would approach that in disbelief because it didn't make sense. So what happens is the microscope takes you to a new place where your senses can now bring in more of the universe than your biophysiology would have otherwise enabled. And a telescope goes in the other direction. Then you have particle accelerators that go much smaller than even microscopes go. So here are bits and pieces of the universe coming to us. At one point, you just have to say, like, to paraphrase you, the universe is what it is, and it doesn't give a rat's ass what you think of it.
Neil, though, in your own words, you say that when you're talking about the light, you say every element, every molecule, no matter where it exists in the universe, absorbs, emits, reflects, and scatters light in a unique way. So that moment when light happens, you can see that is when, I guess what we'll call the transformation to the universe began.
Well, it's a watershed moment in the universe, because after that, atoms were shaped, and now you can make larger molecules from those atoms. Molecules can coalesce, you can make stars, you can make heavier elements, you can make planets, you can make people. So, yeah, so we can't think of the universe as we know it until that moment enabled it, empowered it.
And then you give us another little hint here. You say that what we really have to do is reconstruct the cosmic history in reverse.
Yes.
We can't start at the beginning. We can only start from the point we're at and figure out the beginning by going in reverse.
It's always about how clever are you to figure stuff out. It's always about that. And fortunately, we have experiments in laboratories, particle accelerators, where we can simulate pressures and temperatures that would have been common in the early universe well before the light was set free. And that enables us to say, if the universe were that small and that hot under this much pressure, this would be happening, because we see that in the lab. You make it small, even smaller, even hotter, then this would be happening. And so by this, we baby step by baby step, we work our way back to the very first moments of the Big Bang.
Some of this seems, when you were writing about it, in fact, came after we had the invention of the prism, because that enabled us to let light get refracted and see that there were different temperatures, different wavelengths, different things that...
Yeah, Isaac Newton basically, led that effort with, there was cut glass before this, and light having passed through the glass, making colors, people imagined that the glass somehow made the color. It's not as though the white light was composed of such colors. This was the revelation of Isaac Newton, and he was a good enough experimental scientist to send white light through a prism, see Roy G. Biv come out the other side, red, orange, yellow, green, blue, indigo, violet. That comes out the other side, and you can ask, did this just come out of the glass, or is this white light? So he took these colors, sent them back through, in reverse, through a prism, and out the other side comes white light. And so this was confirmation that white light is composed of colors, and it freaks out artists. Why artists can't wrap their head around that. If you take paint, red, orange, yellow, green, blue, violet, paint, you're not getting white light, you're getting mud.
Actually, you almost get black, don't you? I mean, literally
yeah,
the
well,
opposite.
It's not quite, it's not quite black. I mean, black
right.
is deeper and richer,
yeah.
but yeah, it's kind of a muddy. I tried it once.
Oh, really?
Oh, yeah. When I first learned about the colors, I said, let's try this with paint. And it's a color you would never paint anything with. Yeah.
Really?
Yeah.
I got what it looks like. Okay. Now, as I say, this is from the Big Bang to Newton, so let's really get into.
Yeah, I don't want to step
Newton.
ahead of whatever your timeline
no,
is
you don't
here.
worry about it. We'll step behind, and the viewers aren't going to mind either. But it is Newton, and I don't want to besmirch Galileo, Copernicus, anybody else, but it seems.
That is the first time anyone has ever started a sentence that way.
Really?
I don't want to besmirch Galileo, Copernicus, but
it is Newton.
There's no way to just besmirch them.
I know, but you say it is Newton though that really begins to whatever Newton does is what literally leads to what Einstein's going to do.
Yes, entirely. But I can make a stronger statement than that.
Go for it.
Newton showed for the first time that the universe is knowable, and that mathematics is the language of the universe. In fact, the title, the very full-up Latin title of his greatest work, the Principia, that's what we call it colloquially. That's not the full-up title of his work. The full-up title is The Mathematical Principles of Natural Philosophy.
Of natural philosophy.
Right.
So something you would never even think of applying mathematics to.
Well, exactly. So natural philosophy in the day was what today we would call physics. So it's philosophy as applied to nature, okay? So it could be anything in nature, biology, chemistry, what today we call physics. So now he is finding mathematics as the language of this. And once you do that, it means by manipulating an equation that is itself of the universe, you're tantamount to manipulating the universe. You are, if you say, if this equation describes gravity, then I can do things with this equation and get deeper understanding of how gravity works.
Well then, let me ask you this then. Is that how we eventually get to the distinct forces, by first knowing what gravity is as you call it, binding the bulk of matter? Then you say there's the the electromagnetic force that binds the molecules, the strong force that binds the atoms,
The nucleus
itself, and then this is the one that I was not familiar. I was familiar that there was four, but I didn't get this one. The weak force controlling radioactive decay. I don't know why that one.
Yeah, it's a weird one.
It's a weird one.
It's a weird one, and it's outside of our life experience. So too is the strong force. In our life experience is gravity and electromagnetic forces. By the way, electromagnetic forces, that was two separate forces before we learned they were one and the same. We had electricity, we had magnetism, and we had magnets, and we had, lightning bolts. So they were happily living separately until it was revealed by several people, including Heinrich Hertz and a few others in the 19th century, that these forces are in fact one and the same. The two sides of the same coin. And so we contracted those two words, electricity and magnetism, to electromagnetism. And that is the force that you might not be familiar with, but it enables life itself. It is what binds together all the molecules of your body, this table, this floor. It's why anything has any structural integrity at all.
And again, counterintuitive, and I know it's not for a physicist, but it was for me. When I heard that gravity was one of the weaker forces.
The weakest force, by far.
And of course, in my mind, I'm saying, my gosh, how could that be? It's holding these planets, circulating these suns, but yet, as you can jump and defeat.
Yes, I can take this and lift it.
That's
Again,
right.
Here is the entire mass of the Earth sitting beneath this, and I just use my bicep and lift it away from the Earth.
Well, that's because you've been in the gym for a while.
And
let's
I
be
can
honest.
tell you this, if Earth were a magnet, pure magnet, there's no way you're lifting this away from it.
And
We exploit the strength of magnets to lock doors.
that's right.
Right? You know these buttons you push
Yeah.
before you go through the glass doors? It's not an actual lock. It's just a magnetic field that's set up. And you cannot do that without breaking the door.
And making the strong force, what one would think, again, as I say, is counterintuitive, but that is what's holding the actual atom together. We know what happens once you pull that apart.
And let me tell you how you can remember how strong that force has to be. You may have learned, we've all remembered, that like charges repel and unlike charges attract. Same with magnetic poles. Like poles repel, opposite poles attract. In the nucleus of an atom, you have crammed multiple protons, depending on how big the atom is itself. Protons, they're all the same charge. Carbon has 6 protons crammed in one small volume. How's that even possible? Don't they want to fly apart? They do want to fly apart. But there's a force operating stronger than their electromagnetic tendency to fly apart. And what else did we call it? The strong force.
You know, I've had numerous physicists on the show, some astrophysicists, some on the quantum
So I'm
scale.
not your first? Oh.
So you're not my first, but you're my best. Okay. But here's the thing that I
He
thought.
whispers.
Yeah, I don't want any of the others to hear. Here's the thing, though, that you brought into the conversation of the cosmos that I've not seen brought in before. You love the periodic table.
Love me some periodic table.
And therefore, I was thinking that's chemistry. How is that existing why is it here? But my gosh, you realize that the periodic table is almost on a micro way of understanding the macro of the cosmic universe.
Yep.
If you follow that table, you follow the creation after the Big Bang.
That table is a repository of not only what the universe is, but the history of discovery within the universe. Not all elements were discovered at the same time, not even by the same countries, not even by and all under different motivations. And so yeah, I'd love me some periodic table. I had to give an entire chapter to that.
Oh, and the other thing.
I hope you enjoyed it. I'm glad
I loved it because you know what
Yeah.
it is? It made it more understandable of how, you know what it really did for me? It goes back to that example of reconstructing it backwards. The periodic table really helps you see how the elements were formed, so you can see how it moves back into understanding the cosmic reaction that took place after the Big Bang.
Plus, there's some fun parts. For example, there's an element discovered on the sun before we discovered it here on Earth. And so we named it of the sun, after the Greek god Helios of the sun, and that became the element helium. And so these are these bits of history on the periodic table. The element uranium was named after the planet Uranus because the element was discovered shortly after the planet was discovered, and they wanted to give it some lofty cosmic meaning and significance. And then Neptune was discovered, and after that, the element we would ultimately call Neptunium would be named. That slot right after uranium on the table was reserved for that next planet, Neptunium. And guess what? After Neptunium, there's another element named after the cosmic object discovered in 1930 that we called Pluto.
Plutonium.
And this is where you get plutonium from.
Yeah.
So those are named
We have
after...
to change it now, by the way?
I'd take a Sharpie. Wherever I see the chart, I'd cross it off. No. Pluto got in on false pretense, but that's part of the history of the chart. So you have these... so the fact that these are 3 elements in a row, one slightly heavier than the next, it's for me, the periodic table is this repository of our greatest quest there ever was, the manifestation of our curiosity in understanding what the universe is made of.
What the universe, though, is made of is also shapes. And what you let us know quite bluntly is the shape that influences everything is the sphere. The sphere seems to be not seems to be, I've got to be careful, I'm talking to a scientist here. It is the dominant shape of everything in the universe, by far.
Well, so
there are others, you say, but that's the dominant shape.
let me say it a different way.
Okay.
Let me say, so the forces of nature conspire to want to turn things into spheres. And if ever there is something cosmic, some cosmic object that is not a sphere, it's usually really interesting why it's not. Is it rotating really fast so that it flattens? Is there something else going on that, for example, if an object is small, then gravity loses in its effort to make a sphere against electromagnetic forces that'll shape it into whatever it wants. This is why small moons, like the moons of Mars, they look like Idaho potatoes. They're not spheres. They're too small for gravity to have shaped it. And electromagnetic forces kick in, and there you have it. You've got shapes that are not spheres. So in the chapter which you're pointing to now, which is one of my favorite chapters of the book, personal favorites, it's called On Being Round. And it's just a celebration of how it is you get round things in the universe.
Well, you know, one of the terms that run through the book, and I thought, I'm going to get your exact take on it, and it is what you call, and what others I have heard, the cosmic perspective. Because when you have the cosmic perspective, it can do two different things to you. It could either make you feel relatively small and insignificant, or like you said, it could be liberating.
And uplifting.
And uplifting.
Yeah, and exalting. So, yeah, I mean, to learn how small we are in space and in time, and in all these ways that we wanted to historically feel big, can be quite the dismantling of your ego. But what the cosmic perspective also brings to you is an understanding of how connected we are, not only to one another. You can get a cosmic perspective not just from the universe, you can get it from biology, you can get it from chemistry. Biologically, we get that from Darwin in 1859, and confirmed forever since then, that, yeah, I'm different from you, I'm bigger, stronger, no, in fact, we have damn near identical DNA. And the DNA of all humans is strikingly identical. And other animals, the chimpanzee, 99% identical DNA with a chimpanzee, 40% identical DNA with a yeast cell. And you learn that we as living beings on this earth have a connectivity to all other living beings, all other living things on this earth. So maybe that dismantled your ego, but for me it says we are a participant in the great unfolding of this biosphere, this ecological story of which we are a part. And cosmically, you need to bring out the chemistry of our bodies. You look at the elements that comprise life. We find those elements everywhere in the universe. We are not made of special stuff. And you could rank the most common ingredients in the universe in order: hydrogen, helium, oxygen, carbon, nitrogen, and then ask, well, what are the ingredients of life?
You just named them.
Hydrogen. We don't have helium because it's inert, so that no helium. It's not. You can inhale it and sound like Mickey Mouse, but it has no chemical effect on you at all. So pull that aside. Hydrogen in the body, oxygen. Most of that is in water because water is a fundamental ingredient of life. Then you have carbon and nitrogen. We are the top four ingredients, chemically active ingredients, one for one. And you can say, oh my gosh, that means I'm not special. But I say, oh my gosh, you are special, not because you're different, but because you're the same.
And on that note, Dr. Tyson, I'm going to end with your words. We are stardust brought to life, then empowered by the universe to figure itself out. And we have only just begun. Thank you, Dr. Tyson, for helping us figure it all out. And thank you for joining us. Now, before our next conversation with Neil deGrasse Tyson, we'll cover from Newton to Einstein to the present. But before we do, I'd like to leave you with these few more words from Astrophysics for People in a Hurry. We achieve true cosmic vision only after seeing the unseeable, a dazzlingly rich collection of objects and phenomena across space and across time that we may now dream of in our philosophy. I'm Barry Kibrick. Between the vast phenomena across space and time, may our philosophical dreams continue to bring us a true cosmic perspective.
To connect with Barry, like him on Facebook and follow him on Twitter @BarryKibrick. And to contact Barry directly, view past episodes of Between the Lines, and read his weekly blog, visit us at barrykibrick.com. Between the Lines with Barry Kibrick is made possible in part by Sam Ash Music, a proud sponsor of Between the Lines with Barry Kibrick. Sam Ash has been serving musicians since 1924. To unlock your inner musician, information is available at samash.com.